Hey there, it's Justin again. I've been preparing for a robotics competition in science club. Yesterday, I started building a huge robot, but today I had a new idea. Do you know what's better than a big robot? A bunch of small ones. I already designed the battery for the big robot, and it's fully charged with 5 to the 5th power of energy units. I want to use it to charge the batteries for the smaller robots instead. Those small batteries only need 5 to the 3rd power of energy units to be fully charged. I need your help to figure out how many small robots I can fully charge with my original battery. To charge the small robots, we'll need to split up the charge of the big battery. What math operation do we use to split something into equal groups? Yeah, division. We'll divide the energy units in the big battery, 5 to the 5th power, by the number of energy units needed for each small battery, 5 cubed. That'll tell us how many small robots we can charge.
Division can be written as a fraction, so we can rewrite this as 5 to the 5th over 5 cubed. Exponents are just repeated multiplication, so how can we represent the numerator and denominator as repeated multiplication? 5 multiplied by itself 5 times in the numerator, and 5 times 5 times 5 in the denominator. Do you see any way to simplify this? Each 5 in the denominator pairs with 1 in the numerator, making fractions of 5 over 5. What do those simplify to? 1. Now we've got 5 times 5 times 1 times 1 times 1, which is just 5 times 5, or 5 squared. Notice that the pair simplified to 1 and then canceled out, and we were only left with 5s that didn't have a pair.
This means I can charge 5 squared, or 25 small robots. I'll have a whole army of robots for the competition. Before I get started on them though, I wonder, is there a property for dividing exponents like the one we learned for multiplying them?
This problem's throwing variables into the mix. We'll use repeated multiplication to simplify x to the 6th power over x squared. Pause the video here and rewrite the numerator and denominator as repeated multiplication. We have 6x's multiplied in the numerator and 2x's multiplied in the denominator. We'll match up x's from the numerator and denominator to make 2 pairs. Each pair cancels out since x over x equals 1. That leaves us with 4 x's multiplied together, and as an exponent, that's x to the power of 4. Look at the expressions we've simplified. What do you notice about the exponents in the original expressions and in the answers? Pause the video and write it down. The exponent in the answer equals the exponent in the numerator minus the exponent in the denominator. This is called the quotient property of exponents. To divide exponential terms with the same base, keep the base the same, and subtract the exponents. This works whether the division is written as a fraction or with a division sign. Just make sure to subtract in the correct order. For fractions, it's the exponent in the numerator minus the one in the denominator, or top minus bottom. For division written horizontally, it's the exponent in the dividend minus the one in the divisor, or the first minus the second. This property works for any exponents, positive, negative, and 0. Let's try it out with a few negative and 0 exponents. We'll use the quotient property here to simplify y to the power of 0 over y to the negative third power, writing our answer with a positive exponent. Since the exponents have the same base, y, we can use the quotient property to subtract their exponents. The base will still be y, but in what order do we subtract the exponents? It's the exponent on the top, 0, minus the exponent on the bottom, negative 3. What's 0 minus negative 3? Subtraction is the same as adding the opposite, so we can rewrite it as 0 plus positive 3. And that's just 3. So our answer is y to the power of 3. Here's another one. Use the quotient property to simplify 8 squared divided by 8 to the 6th power. Again, we'll write our answer with a positive exponent. The bases are the same, so we use the quotient property to subtract the exponents. In what order do we subtract? The first exponent minus the second one, 2 minus 6. What does that equal? Negative 4. So we have 8 to the negative 4th power. We need to write this with a positive exponent. How do we do that? We'll take the reciprocal and make the exponent positive, giving us 1 over 8 to the 4th. Now it's your turn. Pause the video here and use the quotient property of exponents to simplify each expression. Write each answer as a single term using a positive exponent. For part A, the bases match, so we subtract the exponents. 9 minus 2 is 7. That means the answer is a to the power of 7. For part B, both bases are 3, so we subtract the exponents. 5 minus 8 is negative 3. That gives us 3 to the power of negative 3, which we rewrite as 1 over 3 to the third power. In part C, the negative base doesn't change anything. We still use the quotient property to subtract the exponents. 6 minus negative 4 can be rewritten as 6 plus positive 4, which is 10. So the answer is negative 2 to the power of 10. Make sure to keep the negative 2 in parentheses so the whole base is raised to the exponent. And for part D, we subtract the exponents. Negative 5 minus 0. That's just negative 5, so we get n to the negative 5th power, which we rewrite as 1 over n to the 5th. Ooh, this one's got numbers and variables. It's our job to simplify 8b to the 7th over 4b squared. And as usual, we'll write the answer with a positive exponent. So we have variables with exponents, b to the 7th and b squared. And we have numbers without exponents, 8 and 4. Since 8 and 4 are coefficients that are multiplied by the variables, we can separate the problem into two parts. A fraction with the coefficients 8 over 4, multiplied by a fraction with the variables and exponents, b to the 7th over b squared. Let's start with the coefficients. How can we simplify 8 over 4? By dividing. 8 divided by 4 is 2. Now, as for the variables, how do we simplify b to the 7th over b squared? With the quotient property of exponents, we subtract the exponents 7 minus 2 to get 5. That gives us b to the 5th power. Multiplying these two parts together, we get 2 times b to the 5th, which we just write as 2b to the 5th. So, for problems like this that have exponential expressions with coefficients, divide the coefficients, just like simplifying a fraction, and then subtract the exponents using the quotient property. Try one more on your own. Pause the video here and use the quotient property of exponents to simplify this expression. Write your answer as a single term using a positive exponent. We've got coefficients and variables here, so we separate them into two parts. 6 over 2 times h to the 9th over h to the 7th. Dividing 6 by 2 gives us 3. Then we use the quotient property to subtract the exponents in the second part. 9 minus 7 is 2, giving us h squared. That gives us a final answer of 3h squared.
Thanks for your help preparing for my robotics competition. I'm glad we took the time to think more about dividing with exponents too. We discovered the quotient property of exponents. When dividing exponential terms with the same base, we subtract the exponents. I better get started on building those 25 robots. While I do that, finish your guided notes and complete practice levels 1 through 4. Until next time, keep questioning, keep calculating, and remember, divide with confidence by subtracting the exponents. See you next time.
Hey, hey.